Now, we are going to take up one more problem, the problem number 31. It reads as a rigid beam carrying a load of 50 kilonewton is supported by 3 bars, which is as shown in the figure. All the bars are of the same area and same length. Here, find the load carried by each bar. Neglecting the weight of the beam, take Young's modulus of steel is equal to 2 times the Young's modulus of brass. So this is the figure wherein we have ABC having the length of steel, bar, here brass and steel again. PA is equal to steel and PB is equal to brass, and again PC is equal to steel. A rigid beam of ABC having the load which is acting downwards, which is at a distance of x from A, and similarly the x from B, and also the 2x from the PB. So this is the rigid beam, and neglecting the weight. So as we know, we have AA1, and the deflection at the delta A is the deflection at A, and delta B is the deflection at B, and delta C, which is the deflection at the C. And here we have AA1, BB1 and CC1, and AA2, BB2 and CC1, and this is the delta C. This is steel, and DA, EB and FC are the length of the steel, brass and steel wire. So as the load is acting downwards, so therefore the tension in the steel wire will be PA, and the tension in the brass wire is BB, and the tension in the steel wire again, which is on the C, which will be PC. So now we will try to solve this problem. So to do that, let PA, PB, PC be the tensions in the bar of AD, BE and CF respectively. From the equilibrium condition, what it says, when you are taking the equilibrium condition, the sum of the force which is acting downwards will be equal to the sum of the forces which is acting upwards. So that means PA plus PB plus PC is equal to 50. So that is according to this. So taking the moments about the point A, when you are taking the moments about the point A, sum of the clockwise couple will be equal to sum of the anti-clockwise couple. So that means we have 50 into x will be equal to PB into 2x plus PC into 4x. So that is what we are getting this. So now on simplification, you are going to get it as 2 times PB will be E plus 4 times PC will be equal to 50, because x is taken as common and x is on the both on the left hand side and the right hand side. So x will automatically get cancelled. So 2 PB plus 4 PC is equal to 50. Again on further simplification, PB plus 2 PC will be equal to 50. Or 25. So from the above figure shows the position of the rigid beam after the application, or the below figure shows the position of the rigid beam after the application of load. So that is, we have from the similar triangular principles, what we have is AA2 by BB2, which will be equal to 4x by 2x. So that is what from the similar triangle principles, what we're going to get. So A1, A2 by B1, B2 is equal to 4x by 2x. What is A1, A2? So if you are considering that, A1, A2 will be equal to delta A minus delta C. What is B1, B2? Which is nothing but delta B minus delta C in terms of deflections, what we are talking about. Delta B minus delta C will be equal to 2, because 4 by 2 is equal to 2. On cross multiplication, let delta A by minus delta C will be equal to 2 delta B minus 2 delta C. Take this delta C to the left hand side. So delta A plus delta C will be equal to 2 times delta B. So then what happens? Also delta A is nothing but PA into LA by ES into AA, or PA into LA by EA into AA. And delta B will be equal to PB into LB by EB into AB, and delta C will be equal to PC into LC by EC into AC. Here we have used as here you can also use EA or ES, that is because it is the Young's modulus of bar A will going to be the steel, and here also you can use either EC or ES, because the Young's modulus of the steel, the C will be steel wire will be C will be equal to the steel wire, which is BS. And of course the brass is B, which is used as B only. So then what is that? PA into LA by ES into AA plus PC into LC by EC into AC. So that is what we are substituting these values here, which will be 2 times PB into LB by EB into AB. So as we know that length of A, B, C are equal and area of cross section of ABC are equal and ES is equal to 2 times EB. So what happens? Everything will going to get cancels, and then for PA by 2 times EB, because ES is equal to 2 times EB, plus PC by 2 times EB. Again PC, because C is again which is equal to steel, we are considering 2 times EB, which is equal to 2 PB by EB. Then what is that? On further simplification, PA plus PC will be equal to 4 times PB. So what is PA? So from the equilibrium condition, what we know, PA plus PB plus PC is equal to 5 times is equal to 50. So PA plus PC is equal to 4 times PB. So you substitute that PA plus PC is equal to 4 times PB in the equilibrium condition equation, which is that is at this particular point. So what we are trying to do is we are trying to apply that here, PA plus PB plus PC is equal to 50. So we know that PA plus PC is equal to 4 times PB. So you substitute that value here. So that becomes 5 PB is equal to 50 kilonewton. That's what we have written here, which is PA plus PB, PB plus 4 times PB is equal to 50. Therefore, PB is equal to 10 kilonewton by simplification. So once you know the value of PB, so what is that? Again, so 10 plus 2 times PC is equal to 25. So again, from the equilibrium equation, you will going to get it as 25. So PC, you will going to get it as 7.5. Then substitute this in the equilibrium equation, which is PA plus PB plus PC. PA plus PB, you know that is 10, plus PC, you know that it is 7.5, which is equal to 50. So then PA will be equal to 32.5 kilonewton. So this is how you will be able to solve this problem. Thank you.